So, here the natural resources are often classified into renewable and non-renewable resources. Renewable resources. Renewable resources are generally living resources like fish, coffee, forest, etc., which can restock, or that is which can be renewed, whereas non-renewable natural resources are non-living renewable natural resources such as soil, water, wind, tides and solar energy. So, resources can also be classified on the basis of their origin, that is biotic and abiotic. Biotic resources are derived from animals and plants, that is the living world. Biotic is a living component of a community, for example organisms of plants and animals, whereas abiotic resources are derived from the non-living world, example land, water, air. Mineral and power resources are also biotic resources. Some are derived from nature. In biology and ecology, abiotic components are non-living chemicals and physical factors in the environment which affect ecosystems. So, coming to classification of resources, again we have seen that the renewable, non-renewable, biotic, abiotic, energy, raw material and foodstuff. Let us discuss about water resource. Water resources are usually renewable resources which naturally recharge. Overexploitation occurs if a water resource is extracted at a rate that exceeds the recharge rate, that is at a rate that exceeds the practical sustained yield. Coming to forest resources, forest is overexploited when they are logged at a rate faster than reforestation takes place. Reforestation completes with other land uses such as food production, livestock grazing and living space for further economic growth. Now, let us discuss about the individual resources. Coming to forest resources are various types of forest in world according to climate. Features of forest depends upon the climate because different type of climate is found in different regions. Further, there are various types of forest, that is first one, the tropical evergreen rainforest. These forests grow in areas where rainfall is more than 200 centimeters. They are mainly found on the slopes of Western Ghats and the northeastern regions of Arunachal Pradesh, Meghalaya, Assam, Nagaland and the Terai regions of Himalayas and the Andaman groups of islands. The trees in these belts have dense growth. The important varieties of trees are sishu, chap, rosewood, mahogany, bamboos, garjan and sandalwood. Coming to the second type, the deciduous or monsoon types of forest. These forests are found in area where the rainfall is between 100 and 200 centimeters. These forests grow on the lower slopes of Himalayas, Assam, West Bengal, Jharkhand, Odisha, Madhya Pradesh, Chhattisgarh, etc. and the adjoining regions. The trees of these forests shed their leaves during dry winter and dry summer. The main trees are teak, sal, sandalwood, deodar, blue gum and bamboo. Dry deciduous forest and scrubs. These forests grow in area where the rainfall is between 15 and 100 centimeters only. These are found in areas of central Deccan plateaus, southeastern of Rajasthan, Punjab, Haryana and part of Uttar Pradesh and Madhya Pradesh. Dwarf deciduous trees and long grasses grow in this region. Most of the area is used for agriculture. The other type of vegetation is desert vegetation. These types of vegetation grow in area where rainfall is less than 50 centimeters. Mostly thorny bushes, babul and sand bundling grasses are found in this vegetation zone. The Indian wild date known as khajurs commonly in these deserts are found. These plants grow far apart from each other. They have long root and thick fleshy stems in which they store water is for surviving during the long drought, and these vegetations are mainly found in Rajasthan and part of Gujarat, Punjab and Karnataka. Coming to mountain forest vary considerably along the slopes of mountains. on higher slope between 1500 meters to 3500 meters. The coniferous trees such as pine, fir, oak, maple, deodar, laurel, spruce and cedar grow in this region. At the higher altitude of the Himalayas, rhododendrons and junipers are found. Beyond these vegetation belts, alpine grasslands appear up to snowfield. When the water moved to the underground from surface is known as surface water, and it moves through the cavities, fissures, bedding planes, and the water depends upon the structure of the rock. Water which flow under the ground and collected in rocks are known as saturation of rocks. When it submitted under it is known as saturated zone, and water which is collected on saturated zone is known as water table. Underground water is found in three ways, that are saturated zone, unsaturated zone and the rock flowage. In this permanent spring, first we discuss about the wells. Wells have an importance from very old age, and wells are dug at that places where the availability of water at underground is present. Wells which depend upon the rain are of less depth. They used to remain dry at summer seasons. Wells which are more in depth remain for longer time. Coming to artesian wells, these are natural wells. Because of them only water come on surface for its formation of these types of well. Special type of structure is required. One is synclinal and other one is monoclinal structure. Coming to geyser, geyser is the natural source or crack in ground where water comes out, which is also known as spotter. According to Holmes, geyser is of hot water and temperature of water is between 75 to 90 degrees Celsius. In USA, there are 100 geysers in Old Faithful. In India, it is in Orissa, Maharashtra, Gujarat, Haryana and Kashmir. Coming to temporary spring, the thermal spring is simply a point of groundwater discharge whose water temperature exceeds the regional average air temperature. Traditionally, if the water is warmer than 50 degrees Celsius above the average annual temperature in an area, then it was called as thermal spring. In the Banff area, where the average annual temperature is minus 0.4 degrees Celsius, any groundwater that comes to the surface and does not freeze could then be called a thermal spring. Coming to hot spring, hot springs are ponds, portions of a lake or pools in which water has been naturally heated underground. The body of water housing the water can vary in size. Geologists think a particular combination of rocks and minerals found underground work together to create hot springs. It is believed these rocks and minerals trap the springs and allow them to become fermented, which heats up the water. The heated water becomes sterilized and causes bubbles to rise to the surface. Coming to the mineral spring, mineral springs are naturally occurring springs that produce water containing minerals or other dissolved substances that alter its taste or give it a purported therapeutic value. Salts, sulfur compounds and gases are among the substances that can be dissolved in the spring water during its passage underground. Coming to the next important resource, that is soil resources. Soil is one of the natural resources on which all human beings depends, because all the farmers depend on soil for economic and all the vegetation depends upon soil, and the top layer of soil is very fertile, which keep on changing through erosion. Soil also have an order and each order have different characteristics in each type. Coming to soil orders, the orders are based on soil properties as they present in soil: degree of horizonization, presence and ordering of diagnostic horizons, play a critical role in determining the order into which a given soil falls. The actual classification is done on the basis of the appearance of the soil in the field. Presented here is a collection of images and description of examples of each of the soil orders. Each order has at least one example. Additionally, some of the order descriptions also include images of the landscape containing the soil. Along each image is a brief description. The order in which the examples are presented and described is the same as that presented in the lecture. The least developed soils described first and proceeds towards the most weathered soils. Several orders which do not fit the pedogenic sequence logically are included. Through the orders in the sequence, examining soil profiles and order description on which we wish to spend extra time. We will discuss about the O horizon. The O stands for organic. It is a surface layer dominated by the presence of large amounts of organic material in varying stages of decomposition. The O horizon should be considered distinct from the layer of leaf litter covering many heavily vegetated areas, which contains no weathered mineral particles and is not part of the soil itself. O horizons may be divided into O1 and O2 categories, whereby O1 horizons contain decomposed matter whose origin can be spotted on site, for instance, fragments of rotting leaves, and O2 horizons containing only well decomposed organic matter, the origin of which is not readily visible. Coming to P horizon, these horizons are also heavily organic, but are distinct from O horizons in that they form under waterlogged conditions. The P designation comes from their common name, that is peats. They may be divided into again P1 and P2 in the same way as O horizons. This layer accumulates iron, clay, aluminum and organic compounds, a process referred to as eluviation. Coming to A horizon, this is the main article, that is the humus. The A horizon is the top layer of the soil horizons or topsoil. This layer has a layer of dark decomposed organic materials which is called humus. The technical definition of an A horizon may vary, but it is most commonly described in terms relative to deeper layers. A horizons may be darker in color than deep layers and contain more organic material, or they may be lighter but contain less clay or sesquiquites. The A is a surface horizon and as such is also known as the zone in which most biological activity occurs. Soil organisms such as earthworms, potworms, arthropods, nematodes, fungi and many species of bacteria and archaea are concentrated here, often in close association with plant roots. Thus, A horizon may be referred to as the biomantle. However, since biological activity extends far deeper into the soil, it cannot be used as a chief distinguishing feature of an A horizon. Coming to E horizon, E being short for eluviated is most commonly used to label a horizon that has been significantly leached of its mineral and or organic content, leaving a pale layer largely composed of silicates. These are present only in older well developed soils and generally occur between the A and B horizons. In regions where this designation is not employed, leached layers are classified firstly as an A or B according to other characteristics and then appended with the designation E. In soils that contain gravels due to animal bioturbation, a stone layer commonly forms near or at the base of the E horizon. The above layers may be referred to collectively as the solum. The layers below have no collective name, but are distinct in that layer are noticeably less affected by surface soil forming the processes. Coming to B horizon, The B horizon is commonly referred to as subsoil and consists of mineral layers which may contain concentrations of clay or minerals such as iron or aluminum oxides or organic material moved there by leaching. Accordingly, this layer is also known as the eluviated horizon or the zone of accumulation. In addition, it is defined by having a distinctly different structure or consistency to the A horizon above the horizons below. They may also have stronger colors, that is high chroma, than the A horizon. As with the A horizon, and the B horizon may be divided into again B1, B2 and B3 types under the Australian system. B1 is a transitional horizon of the opposite nature to an A3, dominated by the properties of the B horizons below it, but containing some A horizon characteristics. B2 horizons have a concentration of clay minerals or organics and feature the strongest pedological development within the profile. B3 horizons are transitional between the overlying B layers and the material beneath it, whether C or D horizon. The A3, B1 and B3 horizons are not tightly defined and their use is generally at the discretion of the individual worker. Plant roots penetrate through this layer, but it is very little humus. It is usually brownish or red because of the clay and iron oxides washed down from A horizons. Coming to C horizon, the C horizon is simply named so because it comes after A and B within the soil profile. This layer is little affected by soil forming processes, that is weathering, and the lack of pedological development is one of the defining attributes. The C horizon may contain lumps or more likely large shelves of unweathered rock rather than being made up solely of small fragments as in the Solum. That is, the ghost rock structure may be present within these horizons. The C horizon also contains parent material. It forms the framework of the soil. The A and B layers are formed by this layer. Coming to D horizon, D horizons are not universally distinguished, but in the Australian system referred to any soil material below the Solum that is unlike the Solum in general character, is not C horizon and cannot be given reliable designation. Coming to R horizon, that is the bedrock, the R horizons denote the layer of partially weathered bedrock at the base of the soil profile. Unlike above layers, R horizons largely comprise continuous masses as opposed to boulders of hard rock that cannot be excavated by hand. India does not have good resources of iron ore in the world. From the metallic content ranging from the metallic up to 5% or more, they occupy a very high position in the world. Here we find 4 types of iron ore types, that is magnetite, hematite, limonite and siderite. So, these are based upon the iron content, that is Fe content in these 4 categories. Here we will discuss about coal. Coal, often called black gold, is the second largest resource of energy, contributing 27% of global energy production after the gradual decline of its use, especially since World War II. Its consumption has again picked up since 1980. Developing countries like India and China still fulfill nearly 3/4 of their energy requirement from coal because of its huge reserves and cheaper availability. Since 2000, use of coal inversed at a rate of 2% per year. This consumption rate is highest in China, that is 24%, followed by USA 19.8% and CIS 12% and Europe nearly 10%, and USA has the highest coal reserves of both superior and inferior varieties of coal. Nature and origin of coal. Coal, petroleum and natural gas are termed as fossil fuels, as these are derived from the fossils of the dead plant and organisms. Coal is found in the sedimentary rocks of the earth's surface. It is solid amorphous substance varying in carbon from brownish and hardened. The process of decay of this vegetation matter was slow, as little oxygen would penetrate it. Thus, peat was formed. The change from peat to coal was brought about by the peat buried by clays, silts, sands and mud, and the pressure of these overlying material compacting the peat and furthering certain chemical changes. Coming to type of coal, carbon is a major constituent of coal, which is formed due to partial oxidation of woody matter. This element imparts the black color and burns with little flame, high heat and practically no smoke. The other constituents of coal are hydrocarbon, moisture and ash. The heart value of coal, carbon and hydrocarbons form the basis of classification of coal into various types. The anthracite. Anthracite is hard and dense coal which is relatively free of iron compounds and moisture. The amount of fixed carbon may be as high as 95%. It is jet black, luster and has a fine texture. It burns with a blue flame and gives no smoke. The major deposits of anthracite occurs in eastern parts of USA. Bituminous. Bituminous coal is usually black and highly lustrous. The moisture content is relatively low. The fixed carbon content range from about 50 to over 80%, and that of bituminous coal occur in Appalachian Plateau region in the USA. Coming to lignite. Lignite is also known as brown coal. The higher grades vary from dark brown to almost black. It is characterized by high moisture content, generally about 40%. The fixed carbon content is also about 40%. The structure is fibrous and sometimes woody. USA and Russia have large deposits of lignite. Extensive beds of lignite occur in North German lowlands also. Coming to peat. Peat occurs in bogs, especially in areas of cool temperate climate. The largest deposit occurring are Ireland, Scandinavian, Finland and Russia. It is converted into smaller bulk through briquette. Peat is a bulky fuel. Coming to production of coal. Coal is not only a fuel but also as industrial raw material. As many as 2 lakh byproduct of coal are known to have developed so far. Chief among them are: pitch is a tar used for making metal road, insulating or roofing houses, etc. Anthracnose, oil used paints and insecticides. Motor benzene used in instruments. Benzenes used in the manufacturing of nylon, varnish, paints and scented surfaces. Coal gas used as domestic fuel as well as industrial energy, and in transport naphthalene used for the manufacture of plastic. Light oils are used in the manufacture of synthetic rubber and photochemical production. Ammonia liquid used in the manufacture of explosives, soaps and washing powder, etc. Coming to conservation of coal. Coal is a fossil fuel that is being commercially exploited ever since the industrial revolution. Continuous increase in population and industrialization has put an enormous pressure on the production of coal. Coal can be conferred in many ways, some of which are given as under. That is, wastages in mining can be mined using appropriate techniques and steps. Energy efficiency of plants using coal as fuel should be increased. Low grade coal yielding low energy should be improved through chemical treatment. Wastage and turbines using should be minimized. Locomotive and turbines using steam from coal should be improved and made more efficient. Instead of using directly coal, it should be converted into slurry and then used energy in plants. The formation and types of coal in world. Coal is a natural resource and very important for human being. It helps us in many ways. Coal is a black brown colored conventional source of energy, and carbon is involved in different amount. The coal is divided into 5 parts, that are graphite, anthracite, bituminous, lignite and peat. Coal is main source of energy, and by using coal we made many products like ammonia, naphthalene, etc. Formation of coal. The coal is occurred when the vegetation of Carboniferous period is dumped in the earth interior because of lot of heat pressure. It started converting firstly into the peat, and after peat other good quality of coals are formed. Coming to the coal fields in North America, the USA account for 18.2% of world output. It has nearly one-third of the world's coal reserves. Coal is widely distributed in the USA and is mined in 26 states. The coal fields of USA occur in the following regions: the Appalachian region, the Rockies and the interior region of Pacific. America is the largest producer of coal in the world. The major coal fields are the Appalachian coal field, Eastern Interior coal field, Western Interior coal field and the Rocky Mountain coal field and the Pacific coal field. Coming to the coal fields of Canada, 75% of coal is found in Canada. The prairie provinces, this region has bituminous as well as lignite coal. Coal is found in thick seams of 6 to 12 feet. British Columbia in the Vancouver Island is the major coal scattered deposits of coal which are worked out. Nova Scotia field, here Cape Breton Island is the major coal bearing area. It is put to use in the industrial center of Sydney. Coming to coal field in China, it has the largest anthracite reserves of the world. China is a potential coal producer and occurs almost in all Chinese provinces. The contribution is just one half of China's coal reserves, and the mines are deep coal seams are found in the folded and faulted. The remote area is very far away from populated part of China, has discouraged coal exploitation to a larger extent. Southern and Eastern Asia mine about third of the world's coal. The greater part comes from China, India and Japan. China's coal reserves are the largest in the eastern and among the largest in the world, and it consists of the anthracite, which is a much higher grade compared to bituminous, and considerable subbituminous and lignite. Coming to the coal fields of UK, the coal resources of UK have been largely exhausted. The coal deposits are scattered in different parts of the country. Coal lies near the industrial centers. In UK, coal, iron ore and limestone are found in close proximity to each other. Coal is mined in the following areas of UK: the northeastern coastal area, the northeast Pennine coastal area, the Lancashire coal area, the Midland plain coal field. In this chapter, we have discussed about the classification of resources, and these resources, they are both renewable and non-renewable, and type of various natural resources like the energy resources, the mineral resources, etc. And in this we have discussed about the forest, soil, water and the renewable and non-renewable energy sources.